So today's goal is all about understanding how to calculate measures of tendency when given data. So data could be a set of numbers, a set of averages, a set of people's name, a set of people's height, things like that, right? And in statistics, we have three common measures that we use. Now, central tendency, when you hear about it, the word central tendency is where do most of the information lie? Okay? So when you think of central tendency, we're talking about a way for us to figure out where most of the information is actually lying in our data or information that we collect. So there are three different measures of central tendency. Okay? I call these the three M's. They are the mean, the median, and the mode. Now, these three things are going to be your best friend when we do statistical analysis. For a lot of the stuff that we're going to be studying will require to either have the mean, median, or mode in later distributions that we will study at the end of the course. So when you talk about the mean, we're actually talking about this. We're talking about the average of things that are in the set, okay? When we talk about the median, we think about the median as an ordered set's middle datum. So datum is the singular for data, okay? So I look at it as if I have the entire set, I've ordered it from smallest to largest, then it's the middle point in that set. The next thing, the mode. You want to think of it as the data that occurs the most in the set. That's all you really need to know. So that's what we're trying to focus on for this lesson. Okay, we're going to study the mean, the median, and mode. So remember, the mean is the average. The median is the middle of the data. Remember, the information has to be ordered, and you pick the middle. The mode is you order them from smallest to largest, and you pick the set that has the subset that has the most values in it. All right, so let's go and focus on the formulas for all of these topics: the mean, the median, and the mode. So there are different kinds of mean, okay? There is a mean for a population and a mean for a sample. When you talk about the population of something, we're talking about everyone in the group. So if I was talking about Canada, when I'm looking for the mean, I'm actually talking about something from the census. But let's say that I was looking for a smaller subset, the mean of a smaller subset. That means I'd be using part of the population. So instead of getting the census for Canada, we would get, say, the census for Ontario within Canada. Okay? So for this one, we'd say part of a population. Okay, so now let's discuss the actual symbols we use for mean for a population and then mean for a sample. So here's what we do. For mean, we use this. We use this symbol mu, okay? If you ever see the symbol mu, this is actually for a population. So what we're doing is we're adding up all of the people or all of the data from the population. So this is what it would look like. So we'd add up all the people in the population, okay, plus xn at the end, and then divide by the total number of people, okay? Now, in math, we hate writing stuff like this, okay? This upsets us. So what we use is this thing. We call this the sigma notation. We say this is sigma of xi, where I equals 1 to n. And then we divide by n. And that sigma basically says take all of the integer values from 1 to n and use x sub 1, x sub 2, x sub 3 all the way up to x sub n, and then just add them all together. That's what that means. That saves us a lot of time, okay? Now, remember, this is called the population mean. So this mu thing that we have, I got to add this little tail here. This mu thing is what our population mean is. Now, when we have a sample mean, we're not going to visit everybody in the entire set, in the entire population. So we call that x bar. Okay, so x bar we call the sample mean. And when we do that, it's exactly the same, except it's x1 plus x2 all the way to x to the m, where m is less than the n value of the population divided by m. And it's sigma notation. We don't have to put the xi, just write sigma x for anything in the set over n. Now, this one, the way I've written it, this is the formal version of the mu, the population mean. This is what most mathematicians write when we're doing our calculations, okay? So now let's just make sure that we know what the sigma notation is. Sigma means the sum of. So sigma is the sum of. So when you see this, so when you see sigma x, we say that means the sum of all the x values within either the set or the population. So just remember, when we're doing our math work, we can use this. If we're doing some sort of formal calculation, you're going to call it sigma x equaling this. And we're done. So now, how the heck do we calculate the median? So when we calculate the median, this is what you need to do. We arrange our stuff from smallest to largest, and then we find the middle value. Now, if there is two middle values, i.e. we have an even number of points, then we average them. And so I said here, average your middle values if they're even. So here's an example. So you've got 1, 5, 8, and 10, right? And with 1, 5, 8, and 10, you'll notice that there is no middle value. The middle is actually in between here. So what we're going to have to do is we're going to have to average these two. Your median is equal to 5 plus 8 divided by 2, which gives us a median of, well, 13 divided by 2 is 6.5. So you can have decimals for your medians as well. Okay? So now finally, the mode. Let's talk about the mode. And now for the mode. Here's the problem. We actually have to do this thing called a frequency table. Think of it as like a tally chart for numbers or groups. And what this allows us to do is it allows us to pick and then pick the most frequent group. Okay, that is what frequency tables do. So that solves us. It actually helps us figure out which things happen the most. Now, the one thing I want you to recognize with a mode that is sometimes there is no mode. And you'll see that within our work. And sometimes there could be multiple modes. And multiple modes could be possible in our work. So now let's go and talk about the effect of an outlier. All right. So let's say I have this set, 3, 5, 8, 12, and 200, right? I would look at this and I would say that this piece of data right here doesn't really belong in the set, because you'll notice that the numbers are really small for this first half of the set here, right? We have 3, 5, 8, and 12. Now, let's go and take a look at what I mean by that. So you would say an outlier is a piece of data that is a great distance from the other data. So if you look at this other data here, it's 3, 5, 8, 3, 5, 8, 12, and then 200. Now that 200 is so far gone, it's going to affect things like the mean or the median of our data. Now, if I look at this set, it's already ordered, right? But let's say that I was looking at, say, the underlined red set. The underlined red set, its median would literally, no, its median would be 13 divided by 2, which would be 6.5, right? But then when we go and tack on this 200 here, the median changes, okay? And the median changes, but what gets even affected more is the mean in this case. So if I took a look at this entire average of this set here, you'd get some number for its mean. And the mean of this underlined red thing here is 14. But when I go and tack on this 200, we get a mean of, we end up with a mean of 114. That's a huge difference from what we had before, right? Now, the next thing that we could look at is the number of, we could look at where the new median is. So if I looked at the median, there's 1, 2, 3, 4, 5 points, right? The fifth point, so the median would be this value here, okay? So it would be 8. The original median was 6.5. So we've changed the median and it didn't change too much. But when we added that 200, the mean had changed from 14 to 114. So, what you need to be careful of is when you see an outlier, the outlier drastically changes the mean more than the median. All right, let's go and do this question here. So now we have two classes, and for those two classes, we have this list. Okay, we have class A and class B, right? And we need to measure the measure of central tendencies for both classes. So what we need to be able to do is we need to be able to calculate the mean of class A. So when we're doing this problem, it's asking us to figure out the measure of central tendency for both classes. In order to do that, we're going to have to organize class A's number sets from smallest to largest, and also class B from smallest to largest. So let's quickly go through this. The lowest mark in class A is 45. So I'm going to put down 45. So for class A, we're going to have a list of, I'm going to start with 45. We're going to cross off 45. Find the next biggest number. The next biggest number in our set is 51. And cross it off. And we do this until all our numbers are taken care of. So now we've got our lists organized from smallest to largest, and then we need to calculate the measure of central tendency, which are the following. You need the mean, the median, and the mode. Now, in order to calculate the mean and median, we need to know how many points are in the first set and how many points are in the second set. So we have for the first class, we have 17 kids. And for the second class, we have n equaling, how much is that? 26 kids. So what you have to do is you have to calculate the mean of class A, the mean of class B, then you have to calculate the mode. So let's go and calculate the mean of class A. Mean of A is equal to the sum of A divided by 17. Please take a moment and correct that list. I needed to make sure that we have 84 in the list. And now we can do our sum. So now adding up all those numbers, you end up with the following. Well, this is just 1215 divided by 17. And that gives us a mean of A equaling 71.5. So now just pause the video and calculate the sum, calculate the mean of class B. Now, you didn't have to go and organize the stuff from left to right for class B in order to calculate the mean. You could have easily just added all of these numbers up and then divided by 17. So pause the video, calculate the mean, and then let's see if you get the same answers. So doing your calculations, you're going to get the following numbers. So you're going to get 67.0 for our mean for B. And like we said before, 71.5 for the other. Now, the next thing that we're going to calculate is the mode. So let's go and, no, not our mode, but our median. So let's go and take our information and see what we get. So for me, I actually have to start by copying my list that I have here. And what we'll do is we'll calculate our median for class A, and then you will do the same for class B. So for the median, you need to remember that n is 17. So here's what you need to do. In order to find the middle, we need to take n and divide by 2. So in this case, our middle is 8.5. Now, the middle point is 8.5. What you need to do is you need to round to 9. Now, the best part about our middle is that, remember, if you have an odd number, your number that you get is going to be half, but you got to round it up, right? So this position here, this represents the position that we need to go in our ordered list to find our set. To find our set median. So if I want to do that, all I have to do is I just got to count 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, my median which is my middle number, is just, well, 71. All right, so now what I'd like you to do is I'd like you to try and find the median for the even numbered set that we have for class B, and we'll see if you get it. And then what I'll do is I will explain how I came about my answer. Now just remember that this is for n equals odd set. So if my n is an odd number, then our n, remember, we always have to round up to get our point, to get the position that we need. Okay, see what you come up with for the second one. And remember that this is the median for class A. Calculate the median for class B. All right, so for the median of B, what we're going to be doing is we need to figure out what the middle is. Now, since n is even, our middle is going to be the following. We're going to go 26 divided by 2, you get 13, right? But because this is even, we need to sample the 13th and 14th number to get the median, because we have an even number in the middle. So let me show you what I mean by that. So what we're going to do is we're going to count to the middle. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? Now, here is our 13th position, right? But then here is our other position, our 14th position, because the middle is actually in between these two. Another way of looking at this is if I counted from the outside into the center, we'd have both our fingers right beside each other at 73 and 73. And what you do is for every time you have an even calculation, your median is equal to the average of the left number, which is 73, and the second number, which is 73, and divide that by 2. And now you get a median of 73. So This is how we calculate our median for n is equal to even. So for our medians are set up in such a way that we have two different ways of doing them. Okay? And that's it. We have one for which we calculate the median if it's odd, and one where we calculate the median if it's even. And in this case, the second one, in this case, we average the two middle numbers. And we're done. So let's talk about the final concept of what mean, median, and mode. When we're talking about mean versus median, here's what you need to understand. So because we have sizes of greater than 100 for certain calculations, the mean ends up being better. And in effect, if you think about it, because there's more of the stuff that is normal numbers in the set, the outliers don't affect it as much. But for medians with small sets, the outliers have less effect. On the median. That's all. Now, let's talk about for the mode. The mode only is good for large sets of data. So take, for example, the height of all women, okay, or the height of all men, right? If we had only chosen the small group within our class of 10, that mode for the class size would have no meaning. Yeah. And the reason why that would be is because you might have two people that are the same height, but those two people in your class wouldn't represent the entire larger population. We would literally have to get a larger sample set in order to make this a more meaningful endeavor. So with modes, you must have that large set of data in order for us to use it and make it have any meaning. All right, let's go on to the weighted mean. Sometimes data is grouped or weighted by its importance within a group. Now, when we go and calculate the mean, in this case is calculated as this. You're going to call it x bar is equal to the sum of the weight times the x value. Now, the x value is usually, if it's in a group, you would take the middle of the group. But if it's just a number, you just take the number. Okay? Now, the weight of the group, the weight times x divided by the total weightings that we have for our problem. So let's take, for example, this problem that I've provided for you. All right. A teacher's collected a series of assignments and graded them. Each assignment has a different weight in terms of importance. We need to answer the following. Determine the weight of the weighted mean, okay? Then the unweighted mean, and then we calculate and compare the two. So remember that I told you the mean for a weighted mean is the weight of whatever we're using times the x value that we have. So in this case, for A, if we label all of the weights, we say X is equal to, let's go and put down all the weights. So the weights are 2, 1, 2, 5, and 4. Now, for each one of those weights, we have a certain percentage that is attached to it. In this case, we have 85% for the first one. Then we have 95% for the second, 60, 75, and then 50. Now, what we said here in this thing is we take all those weights times the X value, then we add them all together. So let's do that. And then we divide by the total weight. Okay, now the total weight in this case is 10 plus 5 is 14. And when we go and do our simple math for our mean, notice it has to be X bar still, right? Your final answer is going to be 69% for your weighted mean. Now, let's say that I need to calculate the basic mean for this. So now X bar in this case is just 85 plus 95 plus 60 plus 75 plus 50. And we're going to divide by the overall of 1, 2, 3, 4, 5. 5 spots. And you end up with 73%. And you're going to say is the unweighted mean. So now let's go and compare the results of A and B. So for part C, comparing the weightings, it says here that you'd score higher because you did well on the tasks with less importance in this case. Now, if we want to answer the next problem in this set of questions, it says here, which assignment holds the most value? If I'm looking at this, you're going to say that D, the bad essay, the big bad essay, is most important. And then finally, let's take a look at D. Explain why the teacher uses weightings for their means, for their mean. And for part E, why would a teacher use this? It allows a teacher to let you have more of an impact with certain marks, right? So if the big bag essay is the most important thing, you want that to be affecting the grade more, essentially. So let's say that we have interval data this time. Now, imagine if I wanted to arrange this interval data. So let's say I had the intervals from 0 to 6, 7 to 8, and ... It goes on forever. Well, this is going to be, if I wanted to calculate this as a mean, we're going to use this as an extension of what we studied before. So here is our formula for the mean in this case. We say the mean is equal to Well, the sum of the interval, let's call it the interval x, right? And the frequency is f. So instead of a weighting, we're going to have a frequency divided by the total frequency. So let's take a look at this next problem. So imagine you have 100 students, okay? And they write a university examination. All right. Now, these are the results of their marks from a 0 to 100 is 12, 81 to 90 is 18. So those are all your students. Yes. Now, these parts here represents the frequency that we were talking about. And this represents the x value. But in order to get the x value, we have to go and calculate the middle point of our interval. So the midpoint of the interval is going to be, well, 100 plus 91 divided by 2 is 95.5. And then you do that for the rest of these. So let's zoom in so that I can basically just make this a little easier for everyone to see. All right, so for our mark, our midpoint x is literally going to be 95.5 because we have 100 plus 91 divided by 2. And then we do the same for the next one. We end up with 85.5. Same for the next. 75.5. And we keep going. 65.5 and 55.5 and 45.5 and 35.5. And remember, this midpoint is always the average of the interval. So this one here was 91 plus 100 divided by 2. Now, all we have to do is follow the same pattern that we did when we were calculating our weightings from before. So let's do that right now. So to calculate the weightings, we're literally going to do exactly what we did last time, except this time we're going to be using the weightings that we calculated, the midpoints for our information as our x values. And then this part here represents the weightings that we use. So we basically take 95.5 times 12, 85.5 times 18. So it's frequencies all the way down, and then we divide by the total frequency. Now, sometimes the questions are misleading. They deliberately tell you that there are 100 students, but if you go and add up the frequencies that we have here for our frequency table, you'll notice that this total here is 98. So basically, we have to divide by 98 as our calculation. And so when we do our calculation, we end up with 7,099 on the top divided by 98, which means our mean is equal to 72.4%. So our mean is 72.4%. Now, let's go and calculate the mean, not the mean, the median for this problem now. So let's take a look at how we're going to calculate it. So remember, this was part A, and here is part B. So now, in order to find this, the median has 98 pieces of data, right? So in order to get the middle, we need to take 98 and divide it by 2, so that gives me 49. So if you think about it, here's what's happening. In the middle, we have position 49. And going from the top, counting down, we also have position 49. So the middle point is going to be an average of the two numbers that are at the middle point. So let's go and figure out where that is on our chart. So when calculating these, going from, say, 49 here is 30. Going from here to here is a total of 58. So our final answers are going to actually be in this range right here. Now, because it's in this range and I don't know what the actual number is, I actually have to say that the median is basically just the frequency number that we used before. And that was literally the endpoints of the interval. So you'd say the median is the answers of the interval, which is just 71 plus 80 and divide by 2, which gives us 75.5. Or what you could have done is you could have done this, just gone and read the interval that you had calculated up here and said that your interval where it happens is 75.5. All right. Now, let's move on to the final problem of why this is nothing more than a approximation. See, and the reason this is an approximation is because we used midpoints for the intervals. And that's it. We're done. Now, your homework is going to be online today, and it's going to be a lot of work, because once you're done that, I want you to really practice it, because you're going to have to be able to do this by hand. So now let's go and calculate the mode, since we've just calculated our median and our mean. Now, in order to do our median and our mode, we have to go through each one of these lists and find the number that repeats the most. If I go through this top list here, the number that repeats the most is 71. And that's in our list for A. So if you look at A, 71 occurs exactly 3 times. Now, here's how you would do it if you wanted to keep track of all the numbers, okay? So you'd have a tally. And literally all we're going to do is we're going to keep track of our frequency of all the numbers. So for 45, I have 1. For 51, I have 1. For 55, I also have 1. For 64, 1, ... Eventually, you're going to find that for 71, there is 3. And you go through the rest, and you'll find that none have more than our beautiful number 71. So then T1 is the mode for class A. Is 71. Now, this tally is what you would use is if I just asked you to find the mode for this list, if I didn't care about the median. Okay, so if I needed the median, I'd have to organize this list. But then it also makes it easy for me to spot the number that repeats the most in the list. Now, the mode for A is 71. Try to find the mode for B. Now, if we had done a tally or a number or instead of a tally, maybe this list, you'd find that the mode for this is 61 and also the number 73. So the mode is 71 and 73. And we also have 80. Now we call this set B a trimodal set. Okay. Now, basically, here's what you need to know. If there are more than one mode, it's called a multimodal. It's called a multimodal set. Okay. So now let's go and take a look at the effects of any outliers for our entire set. And we'll also compare everything that's going on in the set. So now let's go and talk about this like a mathematician and try to make sense of what the heck's happening here. Based on our information that we have here, okay, this is our information. So when we compare the two classes, A and B, so this is the answer for part B. So when we compare the two, you could say that class A has the higher average, right? But class B has a higher number set, right? Also, if you think about it, there are outliers in class B. For example, if you take a look, we have certain kids in this class that have a mark of, what was it, 15% and 12%. Now, those kids may have been kids that have dropped the class, but they have severely affected the overall average because what they've done is they've dragged down the mean. By those things. Now, the median wouldn't really have been affected too much. We would still have a chance of having 71 be our median. Not affected. But you see what we told you. I told you before that outliers tend to have an effect on the mean a lot, especially if the numbers differ so far from the actual average, from the original average. Now, for C, we've just answered it. The mean is affected more by the outlier than the median.